So in this video I'm going to explain about the 2020 Polycet paper chemistry questions along with answers. So first time if you are watching my channel, then go to the playlist of Polycet. In that previous paper models all are available with explanations. So and don't forget to subscribe my channel and follow to my channel to get the all information regarding about the educational videos. Okay, without late, I am going to the topic here. There is one question is waiting for you. That is in 2020 Polycet chemistry 91 question is, which of the following is not an oxide? Which of the following is not an oxide? Options are given: bauxite, zincite, pyrrolysite and cinnabar. So these are the options given in those which is not an oxide. So what is the oxide here? In that molecular formula there must be oxygen. That compound have some oxygen in as a element. That's why if you have idea about all the chemical formulas or molecular formulas of all these, automatically you will get the answer. So we know that what's that? Bauxite formula is Al2O3H2O and zincite ZnO and pyrrolysite MnO2 and cinnabar HGS. So cinnabar is nothing but mercury sulfide. In that formula there is no oxygen. That's why it is not an oxide. That's why among the four options, fourth one, cinnabar, is the right answer. So in the metallurgy chapter you must practice all the compounds, metals and their ores. Most important for the competitive exams, at the same time for regular examinations. Okay, see the next bit. In NH3 the bond angle is deviated from normal bond angle 109 degrees 28 minutes is due to. In NH3 the bond angle is deviated from normal bond angle 109 degrees 28 minutes is due to. Options: bond pair repulsion, lone pair repulsion, lone pair bond repulsion and all the above. So here the bond angle is deviated from normal bond angle 109 degrees 28 minutes is due to because of what? Bond pair repulsion and lone pair repulsion, lone pair bond pair repulsion, all the above. So the students who are studying right now 10th class, for them this syllabus is delayed actually. So but you have to watch it because for the purpose of Polycet. So here the thing is NH3 formation. NH3 formation. In that what happened? Let's see that. So here one nitrogen is there. How many electrons are there? 7. Its configuration is 1s2, 2s2, 2p, 3. So here how many valence electrons are there? 5 valence electrons. And what is the valency? Valency is 3. If nitrogen will get 3 electrons, it will get stability. And now here one hydrogen is there, atomic number is 1, its configuration is 1. Nitrogen want to get the stability, for that it must gain the neon configuration, and hydrogen wants to helium configuration. That's why one single hydrogen required one more electron to get the configuration, because He consists of 2 electrons. For one hydrogen is there only 1, it required one more. For nitrogen how many there? 7 there. What is the valency? 3. It may require 3 electrons to get the stability of neon, because neon atomic number is what? 10. So for that purpose they have to form the bond. So what is the necessity of a chemical bond? Every atom must be wants to get the stability. How the stability is possible? When they have outermost shells are almost all completed, or when they are having the inert gases configurations, or what you have to say, octet configuration. When they have octet configuration, they become very stable. For that purpose, they are creating the bonds among the different kind of atoms. That's why here in NH3, what I am saying, N consists of 7, it requires 3, and hydrogen it is 1, it required 1. That's why hydrogen wants to donate the 1 atom each, and next 1 electron each, and nitrogen also giving the 3. Simply to understand that, I am drawing here simply here to get to understand the NH3 formation. Here N, nitrogen. How many valence electrons are there? How many? 1s2, 2s2, 2p, 3. How many there? 5. Simply I am showing like this: 1, 2, 3, 4, 5. So next, plus hydrogen consists of how many? 1. Again, how many hydrogens there in NH3? 3. 1. Again 1. Then we will observe the like this. Here now nitrogen is the central atom. 1 hydrogen, 1 hydrogen, and 1 hydrogen here. So nitrogen will give 1 electron, hydrogen will give 1 more electron. Then the pair, this is what we call pair of electrons. This pair of electrons should be shared by the both nitrogen and hydrogen. Similarly here nitrogen will give 1 and hydrogen also give 1. Here also same thing, 1 1. So here how many there? Here simply 1 2 3 pairs are there already. How many for nitrogen is there? 7 5. So that's why here nitrogen will give 3 electrons and hydrogens will give 3 electrons. 3 plus 3 6. Then 3 pairs will form. 3 pairs will be formed, and 1 more pair is lone pair. This is what we call lone pair. And here it is, I am showing simply here. The nitrogen and hydrogen both will share this pair of electrons. That means what? The pair what it is formed between these two by sharing 1 electron each, that should be shared by the each one. That's why it is what we call bond pair. So here this is the first bond pair, and this is the second one, and this is the third one, and now it is what? Lone pair. Lone pair. So that's why here in NH3 formation, what you have to say, totally 4 pair of electrons are there, but 3 are in bonds and 1 is lone. 3 bonds are pair, 1 2 3, 3 bond pairs are in bond, and this one is lone pair. So due to that, here that should be having some angle 109 degrees 28 minutes. So the availability of 4 pair of electrons, 4 bond pair of electrons in the NH3, then that should be having some 109 degrees 28 minutes. So to understand that, simply I am showing here now one more diagram. It is there. So look here now. This is the nitrogen and this is the hydrogen. Nitrogen, hydrogen, nitrogen, hydrogen. So here I am showing simply this is the one bond and this is the another bond, and now this is the another bond pair. So 1 2 3, this is the first pair, second pair, third pair. These 3 are in shared by the N and H, N and H. That's why what you have to say, 3 bond pairs. And this is the fourth one. What it is that? So that is called here lone pair. Lone pair is 1 and bond pairs are 3. Due to that is having some here angle between the hydrogen 109 degrees 28 minutes. So after that, here due to the repulsion between the lone pair and bond pairs, there is some repulsion between the lone pair and bond pair, because all are electrons. That's why they should be repulse each other. So that's why here when they have lone pair repulsion between the bond pairs and lone pairs, then the angle should be taken as 107 degrees 48 minutes. So this is a very brief explanation for the formation of NH3. After watching this one, just you can go to the textbook and refer it. It will be same as this. So that's why here in these options, third one is the right one. Lone pair and bond pair repulsion is the answer for this one. Due to the repulsion between the lone pair and bond pairs, there is some angle it is there. How much it is? 107 degrees 48 minutes. So this is the third one is the right answer. The concept of hybridization was introduced by Linus Scaling, Linus Pauling, and Berzelius and Max Planck. So the answer is Linus Pauling is the answer. The first thing is, what is meant by hybridization? For this regular batch, there is no syllabus in your textbook as a regular syllabus, because it is in the deleted syllabus. Even though it is deleted syllabus, but you have to check it once. Hybridization is a phenomenon of intermixing of atomic orbitals by the almost equal energy which are present in the outermost shell of the atom. Hybridization is a phenomena of intermixing of atomic orbitals of almost equal energy which are present in the outer shells of the atom. This is what we call hybridization. Hybridization is nothing but intermixing of the orbitals of same energy levels. So after redistribution of electrons also, there is no change in their shape and energy. So almost all similar to the previous one. So hybridizations are three types: sp hybridization, sp2 hybridization, and sp3 hybridization. So I will prepare the one separate video for this topic. So we will go for next one. Children, this is the one of the most important bit from metallurgy chapter, that is based on the high reactivity metals and low reactivity metals and moderate reactivity metals. So the question frame should be in different frames. For example, one type of question should be like this: among the following, which are the high reactivity elements? That is the one question. Among the following, which are the low reactivity metals? Second question. And third one, which are the moderate elements? That is the third question. And now fourth question should be like this, very different and interesting question. That is, here he was selected from different metals from different activity group. He was selected some elements from the high reactivity and moderate and low reactivity metals, and you have to arrange them in a proper order. That is the question given. Very interesting and very important. That's why here in metallurgy chapter you have to remember all the series elements of high reactivity, low reactivity, and moderate reactivity. Here question was given. Look at the question. The correct order of reactivity of metals. Options are given. First option, Na is greater than Zn, Zn is greater than Au, Au is greater than Cu. And next, second option, Zn is greater than Na, Na is greater than Au, Au is greater than Cu. And third option, Na is greater than Zn, Zn is greater than Cu, Cu is greater than Au. And fourth option, Au is greater than Cu, Cu is greater than Na, Na is greater than Zn. Okay, I already mentioned here high reactivity metals and moderate and low reactivity metals. So among these, how he was given. From the high reactivity metals, he was selected Na, he was selected. Na is there. And next thing is, from moderate reactivity, he was selected two elements, Zn and Cu. Zn and Cu. And next thing is, from the low reactivity metals, he was selected Au. Total how many there? Only 4. 1, 2, 3, 4. Among these 4, we have to set them in a order. So already Na is from high reactivity element, that's why it is having more reactivity nature. And after that, what it is? Zn. Next, this is first one, and this is second one, and this is third one, and this is fourth one. So Cu and Au. Na is greater than Zn, Zn is greater than Cu, and Cu is greater than Au. So this is the answer. Now you have to check the same thing in the options, where it is Na, Zn, Au, Cu, it is wrong. Next NaZnCu. So this is the next one. Third one is the right one. Remaining all are wrong. So in this way we will answer the question. So to answer this type of questions, you must have idea about the series of like high, moderate. Go for next question. It is given in on the base of bonding, chemical bonding. So that is here. What is the deficient molecule? What is meant by deficient molecule? In molecule we know that 2 or more atoms are there. So which molecule is said to be deficient molecule? So let's go for that. There is one question is there. Question number 95. Which of the following is electron deficient molecule? Which of the following is the electron deficient molecule? CH4 first option, H2O second option, BF3 third option, and fourth one is the NH3. So among these four, third is the right answer. BF3 is the deficient molecule. Why it is deficient molecule? Let's go for that. The first thing is here, I am going for CH4. CH4 is the methane. That should be having central atom is carbon, CH4 like this. So later we see in detail. Carbon has 6 electrons. Its configuration is 1s2, 2s2, 2p2. Valence electrons are 4. Clear? And hydrogen one it is there. That should be having 1s1. Valence electron is 1. How many hydrogens there? 4. So each one 1. That's why what you have to say, 4 valence electrons there. For carbon, 4 valence electrons there. For 4 hydrogens, 4 valence electrons are there. Then they can form the 4 pair of bonds. Then what you have to know, one bond pair consists of 2 electrons. That's why here 4 pairs are formed. That's why it is completely forming the 4 pairs. That's why it is not deficient molecule, because there are no electrons in that molecule. And next thing, if we can go for H2O. H2O, in that oxygen is there. Configuration is 1s2, 2s2, 2p4. How many valence electrons are there? 6. As usual, hydrogen for each one 1, 2 are there. That's why 2. Again 6 plus 2 means how many electrons are there? 8 electrons. For every bond 2 electrons. That's why what you have to say, 4 pairs are formed. And next thing, that's why no single electron. All electrons which are electrons, all valence electrons are in bonds. That's why it is not deficient molecule. And similarly go for NH3, nitrogen, 1s2, 2s2, 2p3. How many valence? 5. And for hydrogen, 3 hydrogens we have 3. Total is how many there? 8. So again 4 pairs are created. That's why here there is no single electron as alone. That's why it is not deficient molecule. And now we can go for now BF. 3. Boron, 1s2, 2s2, 2p1. How many valence are there? 3. Next, fluorine, 1s2, 2s2, 2p4. How many there? 6. 6 plus 3, 9. Then how many bonds will formed? 4. Then how many it is lone? 1. It required one more electron to form the one more bond. Total in BF3 9 valence electrons are there. Then to form the one more additional bond in along with the 4 pair bonds, it required one more electron. 9 electrons are there. If 10 are there, it will form the 5. But it is having only 9. It required one more electron. That's why it is called deficient molecule. Some electrons are required to form the pair of bonds. That's why it is what we call deficient molecule. Okay. Okay. See the next question. Very important questions for regular SSC and Polytechnic also. It is very important. See the question number 96. In electrolytic refining of metals, the pure metal is taken as options: anode, cathode, electrolyte, and fourth vessel. In every year, one question is coming from the refining of metals. So most probably belongs to this type of question. One time he was asking the impure and one time asking the pure. So here In electrolyte refining of metals, the pure metal is taken as, answer is cathode is the correct one. So you have to remember the impure metal should be taken as the anode and pure should be taken as the cathode. So you have to remember that. And next question, which of the following metals liberates the hydrogen gas? Most important topic in our 10th class. Which of the following metals liberates the hydrogen gas when react with the dilute HCl? So all of you know, when zinc granules and dilute HCl both are reacted together, hydrogen gas is liberated. If you can express same thing in an equation like this, Zn plus 2HCl gives rise ZnCl2 plus H2. So this is a reaction. That's why among the four options, second is the correct one. Zn plus 2HCl gives rise ZnCl2 plus H2. When Zn is liberated with the when Zn is reacts with the HCl, H2 is liberated. That's clear. And next question, the nature of non-metallic oxides is generally. In previous exam in 2021 he was asked the metallic oxides, and in this year he was asking the non-metallic oxide. That's why you have to remember these two. The nature of non-metallic oxides is generally, options are given, basic, acidic, amphoteric and neutral. So acidic is the right answer. So you have to remember these 2 points, no need to confuse. Very simply, metallic oxides are basic in nature and non-metallic or acidic. If you have to remember any one of that, opposite the next one is the right answer. For example, if you can remember, metal oxide is the basic. So automatically what is the basic opposite nature? Acidic nature. Metallic opposite nature is what? Non-metallic. That's why in these two you can remember any one of that, automatically you can recapitulate in the second answer. Metal oxides is basic and non-metallic oxide is the acidic nature. That's why second option is the right one. So it is given on the balancing of chemical equations. So I think everybody know how to balance the equations. The number of atoms which are in a compound on reactants side must be equal to the number of atoms in the products. The same element what it is in the LHS side should be equal to the RHS. Clear? The number of atoms in the reactant side must be equal to the number of atoms which are in the product side. That is what I have to say, law of conservation of mass. So if it is okay, then equation is balanced. So question number 99, which of the following equations is not balanced? So four equations are given. In those equations we have to find out which equation is not balanced. Clear? So first we can go for C plus O2 gives rise CO2. We have to check on LHS side how many carbons are there? 1. On RHS how many carbons are there? 1. And oxygens how many there? 2 atoms are 2. Here oxygens 2. That's why it is balanced. Next, second equation, in reactants how many Ag there? 2. LHS how many there? So generally what we say, this is LHS and this is what it is, RHS. So AgCl how many there? 2 Ag and Cl is 1. Then RHS side how many there? 2 Ag and Cl2. Sorry, here 2 Ag to here simply 2 Ag Cl means here 2 Ag there and 2 Cl also there. That's why here Cl also 2. And next thing here Cl2 how many there? RHS also Cl2 is 2 and 2 Ag also there. Ag is 2 and Cl is 2. So that's why it is also balanced. And next thing is third one, LHS side how many Ca there? 1. And how many CO3 are there? Or simply you will go for carbon 1 and oxygen CaCO3, CaCO3, Ca is 1, C is 1 and O is 3. And RHS side Ca is 1 and O is 1, here 1 and here 2. How many there? 3. And C is how many? 1. Ca is 1, Ca is 1, C is 1, C is 1, O3 and O3. So balanced. And next fourth one, N2 plus O2 gives us NO. Now LHS side, how many in there? Nitrogen 2 there, and RHS as only one it is there. And here how many oxygens there? 2 here. How many oxygens here? Only 1. Here oxygen 2 there, here it is only 1. Here nitrogen 2 there, here only 1. That's why the fourth equation is the right answer, but it is not balanced equation. So fourth one is the correct one. And next question, question number 100. What is the chemical formula of hydronium? So H plus, OH plus, and OH minus, H3O plus. So fourth option is the correct one. This is the direct bit. Hydronium ion is H3O plus. Okay, for 101. The volume occupied by 1 gram of hydrogen gas at STP. The volume occupied by 1 gram of hydrogen gas at STP is 22.4 liters, first option. Second option is 5.6 liters. Third option is 11.2. And fourth option is 44.8 liters. So here we know that at STP H2 can occupy the at STP H2 can occupy the 22.4 liters. 22.4 liters. Then what about H means? Simply we have to do by 2. Then what you get? 11.2 liters. So 2 grams of H2 consists of 22.4 liters at STP. Then at STP 1 gram of H consists of 11.2 liters. That's why here what you have to say, third option is the correct one. Next, the color of phenolphthalein indicator in NaOH solution. The color of phenolphthalein indicator in NaOH solution. So NaOH is nothing but what? Base. In base solution, how the phenolphthalein can behave means that should be turns into pink color. Options are given: pink, yellow, brown, red. Answer is the pink. So in acid basis chapter, one table it is there. In that it is clearly mentioned all the acids and bases, how they can behave, like in different indicators like phenolphthalein, methyl orange, blue litmus paper, red litmus paper. So many things are very clearly explained there. Okay. Next question, one number 103. The functional group in aldehydes is. The functional group in aldehyde is. Actually, the students who are right now studying the 10th class, for them it is the deleted syllabus. Okay. The batch who is studying now 20, 21, 22, for them it is deleted. So even though it is deleted, but it is important. Options are given: OH and CHO, COOH and COOR. The aldehyde functional group is CHO. So this is the right answer. In our textbook, all the functional groups are given in a table form. Just look at once. Important question. For 21-22 batch, it is deleted syllabus, but in coming future it may be applicable to the coming students. That's why I'm going to explain here. Question is, the IUPAC name of CH3, CH2, CH11, CH2. CH3 single bond CH2, single bond CH, double bond CH2 is, what is the nomenclature? What we call that is but 3 in, but 1 in, butane, butane. These are the options. So what he was given? What he was given? CH3, CH2 and CH double bond CH2. So first we have to use the numbers. First carbons. So where it is single bond it is there we have to start it. So simply here 1, 2, 3, 4. How many carbons there? 4 carbons. That's why what you have to say, but. So where it is double bond it is there 1. And already we know that when we have single bond, what you have to say, N, double bond in, triple bond ine. So here 4 carbons are there, we have to say but, and where it is we are given bond group 1, and next thing is what, double bond it is, that's why what you have to say in. If single bond is there we can say n, double bond is there in, and double bond is there ine. Then what you have to do, it is double bond, that's why what you have to write in. So but 1 in. So that is the right option among the 4. Second option is the right one. Interesting question is there, let's go for that. Volume of oxygen required at STP. Volume of oxygen required at STP. Volume of oxygen required at STP for complete combustion of 1 mole of ethane. 1 mole of ethane. So, are you ready? The most important problem it is there, that is important for regular exams and for competitive exams also very important. Okay, see the question. Question number 105. Volume of oxygen required at STP for complete combustion of 1 mole of ethane. For combustion reaction, oxygen is required for what? Ethane. So how many volume of oxygen required at STP? How many volume, how many moles or how many liters it required? Let's go for that. First option 39.2 liters, second option 98.4, and third option 156.8, and fourth option is 22.4 liters. So here the combustion reaction between the oxygen and ethane is given by this one. 2C2H6 plus 7O2 gives rise 4CO2 plus 6H2O. This is a balanced equation. So all of you know at STP, O2 consists of how many moles of O2 consists of 22.4 liters. 1 mole of oxygen consists of 22.4 liters. In that combustion reaction, how many moles of oxygen is there? Here 7 moles of O2. For that, for 1 mole 22.4 liters, for 7 moles how many? Yes, into 2, 22.47, that is equals to what? 156.8. Let us check one. 22.4 into 7, 7 4s are 28, 7 14 6, yes, 156.8. And next thing here, okay, and in this case you observe how many moles of ethane is there here. For 2 moles of ethane, how many moles of oxygen is there? 156 liters of O2 is there. What he was asking in the question, 1 mole of ethane. For 2 moles 156.8 liters of oxygen is required. Now for 1 mole of ethane, simply what you have to do, 156.8 by 2. So that means what? 2 1s are 2 7s are 8, 78.4. So for 1 mole of ethane combustion, 78.4 liters of oxygen required. So this is the answer. So among the 4 options, fourth option, second is the right one. Okay. The distance between the 2 adjacent layers in graphites. So it is in the chapter of carbon compounds. The distance between the 2 adjacent layers in a graphite, options are given: 3 angstroms, 3.35 angstroms, 4 angstroms, 3.6 angstroms. Among them, second option is the correct one. This is the direct bit. And next thing is the formula of chloroform. The formula of chloroform is this is also direct bit. Options are given: CH3Cl, CH2Cl2, CHCl3, CCl4. So CHCl3 is the chemical formula of chloroform. That is the right answer. Next, which of the following is saturated hydrocarbons? Saturated hydrocarbons. So among given options, C2H6, C2H2, C2H4, C4H8. So generally alkanes are called the saturated hydrocarbons. Hydrocarbon means the compounds which have only carbon and hydrogen. So look here, C2H6 only carbon hydrogen, again C2H2 carbon hydrogen, C2H4. The compounds which have only carbon and hydrogen, they are called hydrocarbons. And again hydrocarbons are divided into saturated and unsaturated hydrocarbons. So among them alkanes are called saturated hydrocarbons. So among these four, C2H6 is the saturated hydrocarbon. Okay, next question is very important and very interesting question that should be given on molar chart. Excellent question. Look here once. Which one of the following orbital is possible? He was not asking not possible. Which one of the following orbital is possible? 1p, 3f, 3d, 2s. Among these four, which is possible? That is he was asking. So here already we know that molar chart it is there. Molar chart it is there. Look at there once. So simply what we know, first 1s is there. Next when n is equals to 1, 1s. When n is equals to 2, 2s, 2p is there. When n is equals to 3, 3s, 3p and 3d is there. When n is equals to 4, 4s, 4p, 4d and 4f is there. So he was given 1p. Is there 1p? No, no chance, not possible. Next 3f. F is starting from fourth shell. 4f is there, but 3f is not there. Next 2d. From where it is? D orbital starting? S. From n is equals to 3. 3d is possible, but 2d is not possible. And where it is 2s? S. N is equals to 2s. It is possible. That's why fourth option is the right one. Question number 110. Identify the Daubernier triad which has alkali metals. Chlorine, bromine, iodine, lithium, sodium, potassium, CaSrBa, MnCrFe. So what is the Daubernier triad concept? Triad consists of three elements. X, Y, Z it is there. The average of the besides elements. The average of the beside elements should be equal to the atomic weight of the middle one. The average atomic weight of besides of a triad should be equal to the atomic weight of middle one. So he was asking alkali metals. First group A elements are alkali metals. In those, lithium, sodium, potassium are the group 1A metals. They are called alkali metals. Let us check they are in the triad or not. Lithium 7, sodium 23, potassium 39. So triad is L, Na, K. The average of L and K atomic weight should be equal to the sodium. That is what? 7 plus 39 by 2. What is that? Is 46. 46 by 2 means what? 23. What is 23? 23 is the atomic weight of sodium. So that's why second option is the right one. And next thing is, which of the following compounds is used as the reagent in the preparation of chloroform? Options given: baking powder, baking soda, bleaching powder and washing soda. So bleaching powder it is the right answer. Direct bit that is. And next thing, the equation E is equals to h nu is proposed by. Options are given: Maxwell, Einstein, Schrödinger and Max Planck. So answer is Max Planck, because h is what we call Planck's constant. You have to remember like this: E is equals to h nu. What is h nu? Planck's constant. That's why you have to remember simply the equation is proposed by the Max Planck. Next bit is very interesting bit. Let's go for that. In a given shell, the orbital which has more penetrating power towards the nucleus is. In a given shell, the orbital which has more penetrating power towards the nucleus is. Options are given as P, D, F. In any shell, S, P, D, F are suborbitals there. In those which is very having more penetrating power means, for example, this is plus nucleus K, L, M. This is shell K, this is L, and this is M. Here the electrons which are arranged in s orbitals, those are very near to the nucleus. The shell whatever may be, it is K, L, M, N, anything. Initially where we have to fill in s orbital. That's why the electrons which are in the s orbital, they are very close to the nucleus. That's why they are attracted more. That's why the more penetrating power is towards the s orbital. And next question, this is also interesting question. The total number of inner transition elements in the periodic table. The total number of inner transition elements in the periodic table is. So first you have to know about the, in a periodic table, what are inner transition elements and what are the outer transition. F block elements are the inner transition and D block elements are the outer transition of periodic table. So F block elements are, so third option is the right one. 16, third option is the right one. Okay, next, the maximum number of electrons in the M shell. Next question, the maximum number of electrons in the M shell are. So options are given 18, 14, 16, 32. When n is equals to 1 K shell, that is 1s. N is equals to L shell, 2s, 2p. When n is equals to M, n is equals to 3, that is M shell. When n is equals to 1 K shell, when n is equals to L shell, when n is equals to 3 M shell. Then what you have? 3s, 3p, 3d. When n is equals to 3, that is M shell. For that what you have? 3s, 3p, 3d. So S consists of 2 electrons, P consists of 6 electrons, and D consists of 10. Then 2 plus 6 plus 10, that is what? 18. So 18 electrons in the shell of M. That's why first option is the right one. It is on these two questions are from chemical bonding chapter. 116. In which of the following molecule the bond angle is 107 degrees 48 minutes? Options CH4, NH3, H2O, BF3. Already in this video only I explained about the bond angles, about the NH3. So 2 is the right answer. NH3. So this is what? 107 48 minutes. Okay. Second bit, the number of bond pairs and one lone pair of electrons in H2O molecules are. Options 21, 12, 22, 13. The number of bond pairs and lone pairs in H2O molecule formation. So see here, in the H2O molecule formation, oxygen is what? Atomic number is 8. So 1s2, 2s2, 2p4. So how many valence electrons are there? 4 valence electrons. For one hydrogen, how many there? 1 valence. So then for 4H means H2O. For one hydrogen 1, for two hydrogens 2. So then how many electrons are there? 6. Oh, see once again here. For oxygen 1s2, 2s2, 2p4. How many there? 6. 6 valence electrons. For one hydrogen 1. Then 2 hydrogens 2. 6 plus 2, 8. So in the combination of oxygen and 2 hydrogens, total how many valence electrons are there? 8 valence electrons are there. So then how many pairs will form? Yes, 4 pairs will be formed. So each one carries 2 electrons. So Clear, it's very clear. What it is that in H2O molecule 4 pairs of electrons are there. 4 pairs are there. In those, which are the bond pairs and which are the lone pairs, let's discuss. So here oxygen, it is there. I am showing here oxygen is the red color, and the valence electrons of oxygen also I am showing here 1, 2, 3, 4, 5, 6. 6 dots are there. It means that 6 valence electrons are there. And again hydrogen, each one consists of 1, 1. So in this case we are showing now 1, this is the oxygen. Oxygen will donate the 1 electron. Hydrogen will donate the 1 more electron. Then 1 bond is formed. And next again 1 more valence electrons from oxygen, and hydrogen is giving 1 more electron. 1 pair will be formed. So the total capacity of hydrogen is what? Only 2 electrons. It will use only 2 electrons. That's why these 2 electrons are forming the 2 bonds with the 2 valence electrons of oxygen. Got my point? So very simple. 2 electrons of hydrogens are forming the bonds of with 2 electrons of oxygen. That means what? Simply here 2 is there and here only 2. That means what? 4 electrons are there. These 4 forms the 2 pairs. That's why here I am showing that it is the first bond pair and this is the second bond pair. And remaining 4 electrons are in 2 pairs, and these are the lone pairs. Lone pairs. So 2 bond pairs there, 2 lone pairs are there. That's why what you have to say, third option is the right one. This is the very interesting bit. So watch it once, very important too. Which of the following represents the correct order of electronegativity among halogens? Among the halogens. The given clue is halogens. Which of the following represents the correct order of electronegativity among the halogens? The elements are given F, Br, Cl, I. F, Cl, Br, I. So 7th A group elements are called halogens. 7th A group elements are taken as halogens, and you have to check first they are in the period or group. So F, Cl, Br, I. This is the order of the elements in the 7th A group. First F it is there, next Cl, next Br, next I. So halogens are 7th A group element confirm, and they are in the 7th period like this. Now in groups, electronegativity. While we are moving from top to bottom, electronegativity decreases. That means F is having more compared to Cl. When compared to Cl to Br, Cl is greater, and again Br I we are taken greater. That's why third option is right one. F is greater than Cl. Cl is greater than Br. Br is greater than I. So when we are going from top to bottom, values decrease. That means what? The element which is having the first one is the greater remaining the compared to remaining. Clear? The element which is at the top that should be having more value compared to others. That's why F is greater than Cl, Cl is greater than bromine, and again iodine, like that. So third option is the correct one. 1 nanometer is equals to, nano means 10 power of minus 9. Nano means 10 power of minus 9. That's why second option is the right one. And next question. The element having highest electronegativity is options: oxygen, fluorine, chlorine, helium. So first you have to check the elements which are in the same period or same group. So here helium is very stable, that's why you can neglect it. Helium is very stable, there is electronegativity is 0. And next thing here, oxygen, fluorine and chlorine. When you can go for oxygen and fluorine, both are in the same period, that is second period. Oxygen and fluorine in the second period, and in a period we can go from left to right, negativity is increases. Oxygen and fluorine are in second period. First oxygen is there, next fluorine is there. While we are moving from left to right, electronegativity is increases. That's why fluorine has most electronegativity compared to the oxygen. That's why second option is the right one. Okay na? So if you can understand my concept and if you can feel that my class is interesting, then like, share, comment the video and subscribe my channel to get all the notifications. Thank you.